Welcome back to Maths with Mrs. J. In Year 9 and early Year 10, the trigonometry that you learn is always related to angles that are acute because you're always working with right-angled triangles, as we have here. We learn three main trig ratios. The sine ratio is the ratio of the opposite side to the hypotenuse. The cosine ratio is the ratio of the adjacent to the hypotenuse. And the tangent ratio is the ratio of the opposite side to the adjacent side. Now, all of that still holds. However, we're a little bit limited because our theta, or whatever letter we used for our angle, is always going to be acute in a right angle triangle. Sum of angles in any triangle is 180 degrees. So if you've already got 90 degrees, then obviously your theta is always going to be less than 90. Now we want to expand our horizons and expand our thought processes about sine, cos and tan. In order to do that, I'm going to introduce to you the concept of the unit circle. Let's have a look at that. Okay, we have a unit circle. It is a circle, funnily enough, with a radius of 1. And its centre is at the origin. Now, what's the formula for this circle? You may or may not recall that the general format of a circle is x squared plus y squared equals r squared, where r is the radius. This works when the centre is at the origin, which is the case here, so it's okay to use that. Because r is 1, we get x squared plus y squared is 1. Now, there are various ways that we can talk about the position of a point on the outside, around the outside of this circle. We can talk about our coordinates, our x and y coordinates. All right. We've done that before. We've talked about the Cartesian plane, about the fact that how far across to the right or left you move is your x value, how far up or down you go is your y value, that sort of thing. One thing to bear in mind here is because this is a unit circle, your x values will all be between -1 and +1, and so will your y values. All right, so bear that in mind. Let's move on to our next slide and we will have a bit more of a look at the other different ways that we can refer to this position. All right, so we have our point PAB. We are already familiar with the idea that the x value is A and the y value is B. I want to talk about that in more detail in a minute. Before I do that, I'm going to talk about these other two ways of showing the position of this point P. Theta degrees, we're fairly familiar with angles in degrees by now. What we're actually talking about here is we're imagining that our radius starts off here and it's like a line that's moving, rotating anti-clockwise. All right, so you're moving anti-clockwise. So if you're up, well, at the start it's obviously moved 0 degrees. If you're up here, you've moved 90 degrees. If you're here, you've moved 180 degrees. If you're down here, you've rotated by 270 and back to 360 degrees. All right, we know that in a whole revolution there are 360 degrees. So in our first quadrant, the angle will be between 0 and 90. In our second quadrant, the angle will be between 90 and 180. In our third quadrant, between 180 and 270. And in our fourth quadrant, between 270 and 360. Now, the new bit is this, radians. What on earth are radians? Well, Radians are talking about the distance along the outside, along the circumference that you're moving, starting here to get to your point. Let's think about this for a minute. What is the circumference of this circle going to be? Well, our rule is circumference is 2 pi r. What's our r? Our r is just 1. So our total circumference is going to be 2 pi. So at the very beginning, where there's 0 degrees, it's also 0 radians. And all the way around the outside of the circle is 2 pi. Now, often you drop using the little c because it's obvious if you write 2 pi that you mean radians. All right. So just going through that again, it's a circle with radius 1. So the circumference all the way around is 2 pi. All right, if all the way around is 2 pi, then half the way around would make sense, would be pi. Halfway up here between 0 and pi is going to be half a pi, or pi on 2. Halfway between here and here is going to be 1.5 pi's, which is 3 pi on 2. Now, in our next video, I'm going to talk about and do some examples on how to convert between degrees and radians, which is an important skill. Radians are particularly important for when you're going to be differentiating, all right? Because then we assume that things are in radians, all right? Just be careful there. So that's our next video. For now, I just wanted to consider this point P a little bit more and have a look at this right-angled triangle. And just think back to our very original sine is opposite over hypotenuse business. All right, well, sine of theta is opposite over hypotenuse. What is the opposite side? Opposite side is B. Hypotenuse is 1. So B divided by 1 is just B, isn't it? Now that's actually the same as your Y value. Interesting. Cos of theta is your adjacent over your hypotenuse, which is going to be, in this case, A over 1, which of course is just A. And that's our X value. Tan of theta is our opposite over our adjacent, which is B over A, which is our Y value, divided by our X value. These are going to be the new ways we consider sine, cos, and tan. So any point around the outside of our unit circle, if I want to know what the sine value is there, what I'm really asking is, what is the Y value? And in this particular case, it's going to be, about the sort of 0.45 or something like that, isn't it? Because it's a little bit less than halfway between 0 and 1. Your cos is really asking the X value. So we're down here, about what, negative 0.9 or something like that at that particular point. And your tan is always going to be your Y value divided by your X value, or you can also think of it as your sine divided by your cos. Now that is a lot of information in one video, so I'm going to stop there and do a separate video where we're going to practice converting between degrees and radians.